They're on the front table in the corner. Okay. The first two say to evaluate these roots. Okay? Evaluate, gentlemen. Evaluate just means give the answer. Okay? And what's a really handy tool if we just want the answer?
Calculator.
A calculator, yeah. So we are just typing in the fifth root of negative 248,832. You don't have to make a factor tree. You don't have to do anything like that. We'll talk about what kind of problems you do need a factor tree for, okay, in a second. Sorry, let me take out the iPad, please. Thank you. So 5, and then remember you want to use the x root, which on this calculator is up above the caret key. There we go. So I'm going to hit second x root of negative 248,832 and hit enter. I get negative 12. That's it. That's your answer. Okay. The cube root of 512. Let's do the same thing. So I'm going to hit 3 x root of 512. And I get 8. Easy, easy, right? The first two. There's 2 easy points right there out of 10. Okay? Number 3, assuming x is positive. And again, this is just to tell you you don't have to worry about any of those things like the negatives with the even roots. Okay, this just says assuming x is positive. Suppose this is a square root of a fourth root of x to the 11th. What is the value? Oh, that should say, sorry, that should say equals x to the power of y. Sorry, typo in my review. I don't know what happened there. And then it says, what is the value of y? So that question is just a fancy way of saying, how could I write this as x to some power? What do you think? What can I do with that one, Isaac?
42 times 4 times 11.
Almost. You're real close. Where's the 2 coming from, first of all?
The square root.
Okay, so this root out here that doesn't have a number on it, that's a square root. So we can imagine there's a 2 on it. Okay, let's see if I can zoom this in a little bit. And I can combine the 2 numbers that are roots. So the 2 and the 4 are roots. All right, so I could really think of this as the 8th root of x to the 11th. Everyone follow me there? That I put the 2 and the 4 together. Now, how do you put these 2 numbers together to make an exponent? Say it again. That's right. It's always the inside number on top of the outside number. Okay? So this would really be x to the power of 11 over 8. Now this question just wanted to know what is the value of y, which was the exponent. So really, I just need this number. Would I give you credit if you wrote x to the power of 11 over 8? Probably. But I really just wanted to know what the exponent would be. Okay? So that inside number, that 11, that's going to go on top of your fraction. And then the 2 numbers that make up the root, that goes on the bottom. Okay? All right, number 4, another super easy one. It says estimate to the nearest hundredth. Okay, if it says estimate to the nearest hundredth, what kind of answer do you think you're going to get? A decimal, which means this isn't going to come out exact. But this is basically telling me that a decimal is okay. So where do you think I'm going to get this answer from? Oh, the calculator. All right, so the 6th root of 100. So 6th root of 100 comes out to be 2.15. The directions do say round to the nearest hundredth. If the directions specifically say that, I am going to be picky about that. The hundredth is how many places? 2. Okay, so that's the 5. And then I have to look at that number after it to decide if I need to round or not. Does this round up?
No.
No, so I'm just going to leave it as 2.15. Okay. Number 5. Give a counterexample to the statement for all real numbers k, the 4th root of k to the 4th equals k. Well, what kind of numbers do you think might not work in this? Because remember, a counterexample is proving it wrong. What kind of numbers do messy things here? Negatives, yeah. With radicals, negatives are what usually screw us up somehow. So a counterexample could be any negative number. Somebody pick a negative number.
Negative.
Take it easy on me. -4? Okay. Just so you know, it does not have to be a 4 just because that's a 4. Okay, it can be. But you could do -2. You could do -8. You could do -14 if you wanted to, but I just want you to save me some mental math. So, okay. So my counterexample is going to look like this. I'm going to say the 4th root of -4 to the 4th power. Okay, so I'm putting a negative number in here. Can you tell me what -4 to the 4th power is? And of course you're going to remember. I just want, without the radical, I just want the -4 to the 4th power. But when you put that in your calculator, you have to remember to use what? Parentheses. It's not 16. 4 times 4 is 16. What is it? What did Gabe forget? The parentheses. Yep. So if Gabe had remembered the parentheses, what would he have gotten? Should be positive 256. 4 to the 3rd is 64. Okay, there you go. Okay, so -4 to the 4th is 256. So then I would do the 4th root of 256. Go ahead and figure out the 4th root of 256 for me. It's 4. It was supposed to come back out to the same number we started with. Okay, we started with k equals -4. Is that what it did? Did it come back out to what we started with? No. This is not equal to -4. So that's how I would show a counterexample. My counterexample is the -4, but I want you to show me why it doesn't work. Okay? Any negative number would have worked in there. Okay? Any negative number would have served as a counterexample. But I don't want you to write any negative number. A counterexample is one specific number that does not work. Okay? So, for this one, make sure you show me a specific number. You all could have picked different negative numbers to work with. Okay? But you've got to show me why it doesn't work. Questions on that? Okay. All right, let's look at number 6. The cube root of a plus 5 minus 4 equals -2. All right, this one is kind of tricky because see how this radical covers the 5 but not the 4? That makes a big difference in your problem. Which number is on the outside of the radical, Isaac? Okay, so let's get rid of that -4 first because we always start these problems by getting rid of anything on the outside of the radicals. So I'm going to add 4 to each side. Okay. And so now I have the cube root of a plus 5 equals -2 plus 4 is +2. Okay? Now what? I can't yet because that 5 is underneath this radical. So I can't move it from underneath the radical until I get rid of the radical. Cube it. Yeah. So I need to get rid of this root thing. So let's raise to the power of 3, raise to the power of 3. What's going to happen over here is this root is just going to cancel with that power of 3, and I'm going to be left with a plus 5. So that'll leave me with a plus 5 equals, what is 2 to the 3rd power? 8, yep. And then now I would go ahead and subtract that 5. Okay, and I end up with a equals 3. Before I commit to that as my answer, what do I need to do? Okay, I need to plug it back in. And be careful about how you do this. I'm going to try to show you here how I'm typing it in. Maybe. There we go. I hold it kind of this way. All right. So I'm going to say the cube root. So there's the cube root. Now see how in the problem there are two things underneath the radical? Anytime you have more than one thing under the radical, you've got to use parentheses, okay, to show your calculator that all of that goes together. Morning, Mary. We're just going over the quest review from Friday. Did you pick that up? Okay. Thank you. So underneath the radical, I'm going to say, let's see, a plus 5, and I said a is equal to 3, so I'll do 3 plus 5. Okay? But notice I closed the parentheses before I put the minus 4. Okay? So cube root of 3 plus 5, and then minus 4. Everyone okay with how I got that? Alright, I put this 3 in there for a. Hit enter. Came out to negative 2. Is that what it was supposed to be? Yeah. So I'm good to go. My answer is a equals 3. But it is important to check.
You have to show it every time.
You don't have to show the check. Like if you just want to do what I did and just type into the calculator, that's okay. But the problem is sometimes you'll get those extraneous solutions where you'll get an answer and you'll think, yeah, I did that totally right. And then when you plug it back in, it doesn't work. And then that's a no solution problem. Okay, 7. It's kind of similar to the warm-up. I have the 5th root of 9m plus 8 times the 5th root of 9m. I guess this wasn't the warm-up. This was the question that we went over from the other assignment. Equals 27. So my problem here is that I have two radicals. So I'm going to need to combine them somehow before I can do anything. Any thoughts about how to combine them? Okay, yeah. This is 1 5th root of 9m plus 8 5th roots of 9m. So altogether I have 9 5th roots of 9m. Notice that neither of these changes. Okay, like I didn't change the 5, I didn't change the 9m. All I did was combine. Okay, if you have 1 apple and 8 apples, altogether you would have 9 apples. And that's going to equal 27. What do you want to do now? Okay, divide by 9. That's going to give me the 5th root of 9m is equal to 3. Okay. What now? Okay, raised to the power of 5. And so I end up with 9m equals 243. And then from here I would divide by 9 again. And I end up with m equals 27. But before I do anything, I'd better check and make sure that worked. Okay? So to type it into my calculator, I'm going to start with the 5th root. And because I'm putting two things under the radical, that 9m, I'm going to put that in parentheses. So I'm going to say 9 times 27. Because I got 27 for my m value over here. Okay. Close off my parentheses to show that that's all one root. And then plus 8 times the 5th root. Okay. 8 times the 5th root of, again, parentheses, 9 times 27. It equals, did it come out to what it was supposed to be? It did. Yep. So that works. M equals 27. You did. Let's take a look. Okay, I'm going to scroll back to the beginning and let's make sure that you have the exact same thing. Okay. You want to try again? Okay. Alright, next time that happens, show me and I'll help you with it. Okay, 8. Terrifying, right? Word problems? Freak out time? Don't freak out. Because this is a word problem, But it's a word problem with a formula. And remember, I told you don't ever be afraid of a problem with a formula. Okay? So all of those words are just telling you what the letters in the formula represent. What does the R represent? Radius. What does the V represent? Volume. So then I read the rest of the question. It says, find the radius of a sphere with a volume of 1,040. Where does that 1,040 go? Okay, so it's going in place of V, right? So what we want to end up doing is this. The cube root of 3 times 1,040 over 4 pi. All right, 2 pieces of advice for you here. This one can go straight into your calculator, okay, which makes this easy. However, there's lots of places for you to make mistakes typing this into your calculator. I'm going to try to help you with that. But what I very strongly recommend when it comes time for your test tomorrow is that you write this down, okay? Even if you're saying to yourself, well, I can just type that straight into a calculator, write it out. Because if you do make a mistake typing it into your calculator, you're going to get a wrong answer. And if you don't have this written out, I have no choice but to assume you know nothing, okay? But if you show me this, I know you knew exactly how to do the problem, and then if you had a wrong answer, it's just a calculator error. That's going to be worth way more points, okay, than if you hadn't written that down at all. So please, please, please write that step out. That being said, to try to avoid mistakes in your calculator, what I would do is I would do this in sort of 2 steps. I would do just this fraction first, okay? And watch how I'm going to do that. I'm going to say 3 times 1,040. And then I want to divide by, and the bottom part, because I'm dividing by 2 things, I'm dividing by 4 and pi, that's got to be in parentheses. Okay? So look for a second at how that got typed in. 3 times 1,040 divided by 4 pi in parentheses. So there's place number 1 to make that mistake, okay? And if you had tried to do the cube root at the same time as this, the number of parentheses you would have to use would be kind of confusing. So that's why I would do this separately. I would find this number first. Okay, I get 248.28. And then I would go ahead and type in the cube root of 248.28. Oops, not log. Can't see my buttons. Okay. And I get 6.28. Does it tell me where to round to? No, it doesn't. So I would probably go 6.3. And that's going to be, oh, it didn't give me a unit either. Okay? Questions on that one? All you're doing is plugging that number in for V. Number 9, another terrifying word problem that's really just a formula. Okay? Now this one you do have to be careful about what the letters represent. Your formula is right here. S equals 2 times the square root of 5L. Okay? What does the S represent? Speed. What does the L represent? Nope. That's S. Okay, it's the length of the skid mark. So basically this is the formula that like accident investigators and insurance adjusters use. If you're in an accident, they're going to come out and they're going to look at the length of the skid mark that you left. And that's how they can determine how fast you were traveling. Okay, with a formula like this one. So it says if a car stopped quickly from a speed of 68 miles per hour. So is that 68 the S or the L? That's the S. So I'm going to put that here for S. So look at what that's going to look like. It's going to end up saying 68 equals 2 times the square root of 5L. So this is not one that we can type straight into our calculator because we're trying to find out what L is equal to. Okay? Wyatt, will you pick your head up for me, please? Thank you. So what do you want to get rid of if we're trying to solve for L? Okay, so let's divide by 2. Divide by 2 and I get 34 over here. So I would have 34 equals the square root of 5L. Now what? How can I get inside there? I said? To power 2, yeah, you're going to square it because it's a square root. So to get rid of a square root, we're going to square. 34 squared, I come out with 1156 equals 5L. Okay, and now what? Okay, divide by 5. Divide by 5. 231.2. Okay. And so that would be, all right, if that's in, doesn't tell me what unit that would be in. Oops. I'm betting feet, but we'll just leave it at that. Well, that's what at first I looked at that unit and went miles, and then I went, oh, that's a really big number for that to be miles. So no, I don't think miles. I'm betting feet. Okay, last question. Simplify. All right, now this is different than like questions 1 and 2. Look back at 1 and 2. What were the directions in 1 and 2? Okay, it said evaluate, which literally means find the value or find the answer. Simplify, that's when you don't want to type it into a calculator. Okay, simplify is no calculator. These are the ones where you've got to make a factor tree, and then you've got to pull out whatever you can and leave the rest inside. Simplify means you want to leave it as an exact value. So we're going to need a factor tree for 4,000. Okay? I didn't leave you a ton of room here, I apologize, but you do have the back of your paper if you need it. So I'm going to say 4 and 1,000, and then I'm going to say 10 and 100. This is 10 and 10, which is 2 and 5, 2 and 5. And then this 10 is 2 and 5, and this 4 is 2 and 2. Make sure that you break everything down as far as you possibly can. Okay. So now, and I'm going to take my answer over here. What do I have pairs of in that tree? Name one pair that you see. I see a pair of 2s. So I'm going to put 1 2 on the outside for that pair. What else do you see? A pair of 5s. Okay, so I see 5s here, so I'm going to put a 5 on the outside. What else do you see? Another pair of 2s, right? So I'm going to put another 2 on the outside. What do you have left over? Okay, this 2 and this 5. Okay, so inside the radical I'm going to have a 2 and a 5. I'll put those all back together in just a minute. Let's look at the n. Remember, n to the 9th really means you have like 9 n's. 4, 5, 6, 7, 8, 9. So we can make 4 pairs, right? And if you need to literally write it out, you are welcome to. If you don't need to, you don't have to. So I see 4 pairs. That means I can put 4 n's on the outside with this stuff. And then I have one lonely one left over with no pair. Where's that one go? Back on the inside. Okay, so when I put all these pieces back together, out here, 2 times 5 is 10, times 2 is 20. And then I have n to the 4th, because I made 4 pairs. And then I would have a square root of 10n. And that's simplified. Okay? Can you handle that? Okay, so remember your test looks very, very similar to this. So you have 10 questions that you've got to know how to do. All right? Can you go home and study those tonight and make sure you know how to do all 10 of them tomorrow? Okay. I did record this, So I will put the video up tonight on my website. Let me show you where it'll be.